All right, so I apparently have forgotten all my technology stuff, so we're going to do this one bizarrely styled. Let's go with for section 9.1 over polynomials. Let's talk about the vocabulary in this section because these are words that I'm definitely going to use. We've talked about term and polynomial before. A term is just a number, variable, or a product of numbers and variables. So when we look at a term, we're looking at something like 3x or 2 or maybe even, oops, let's put it up here, or maybe we'd even have negative 5x squared y to the third z. Each of these are considered a term because it's a monomial. Oh, look, we're jumping down a section already. A monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. That is a blessing. It means no fractions in your exponents for now. So those examples that I wrote up above are also monomials. So we can take them and copy them right back down here. So 3x is a monomial, and 2 is technically a monomial. This one actually has a special name. It's called a constant, remember? Constant. And that negative 5x squared y to the third z, it's also a monomial because it's all multiplication. Now, let's talk about a binomial. A binomial is a sum or difference of two monomials. So a binomial, something that would look like that is x minus 3 or negative x squared plus 2 or any of a variety of things, right? A variety. All sorts of things that we can have that are binomial. But the biggest piece is that it's two terms. Two terms in a binomial. So the killer part is that, oh look, can't imagine what 3, a trinomial, would be. It's going to be a sum or differences of 3 monomials. The most common version is the one I'm going to put in your x squareds, or in your example spot. Something like x squared minus 5x plus 10. It has 3 terms, so we call it a trinomial. These we don't usually put in parentheses. Sometimes, but not always. The next 2 vocabulary words that we need to talk about are degree. Now, there are 2 ways to find degree. The first thing you have to do is look at the problem and decide whether you need to do a degree of a monomial or the degree of a polynomial. And I don't think I put it in my last video, but remember that polynomial is a sum or just a monomial. It's another way to say poly means many. So when we say polynomial, we're talking about lots of different terms. And it doesn't matter whether it's a monomial, a binomial, a trinomial, a quadrinomial. It just, once we get past trinomial, we start calling them polynomials. So when you see no additions or subtractions, it's a monomial. And when we find the degree of a monomial, we find the sum of the exponents on the variables. The sum, that means add, of the exponents of the variables. So if we had a problem like 3x squared y z to the third, when we look at the exponents on the variables, we have 2, 1, and 3. So the degree would be 1, 2, 3, 4, 5, 6 would be equal to 6. Now, I want to put a trick problem on here because it happens in your homework, and I'm pretty sure it happens on a quiz. So when I have a problem that would look like this, 8 squared x squared y squared. The degree in this problem is what? Don't say 6, right? Because the direction said the sum of the exponents of the variables. So it's a trick problem, right? This 8 squared is really a 64. So it's really 64x squared y squared. So my degree is really only 4. Now when we do the degree of a polynomial, it's the largest degree of its terms. So this tells us that we should find the degree for each term and pick the largest. Find the degree for each term and pick the largest. And I don't even want to put an example in our example box here because we're going to do some down below. All right, so the first thing you need to do is this bottom pieces, because I think that the first 8 problems are ones you can do on your own. Look at those directions. Identify each as a monomial, binomial, or trinomial. Find the degree of each monomial. And then down here, find the degree of each polynomial. Do those, actually those first 12 problems I think you could do. I know we're going to need to talk about this degree of a polynomial. It's where mistakes tend to happen. So pause the video and give them a try. So I have the first 4 up. And if you have questions, let's make sure we go over them in class, because I'd have to see how you did as an individual on these. Here are the second set of 4. And again, you're checking over your work. And I think the one we probably need to talk about is number 8. Whenever you have a constant and you have no variables, you would say that you have a degree of 0. And here are the last 4 that I asked you to do. And you'll notice that I put underneath each of my terms of my polynomial, I put each term's degree under it, and then I chose the largest for the polynomial. So the degree of each term, and then choose the largest. Degree of each term, choose the largest. Degree of each term, and choose the largest. Now the next piece that we need to talk about is arrange the terms in descending powers of x. This is a skill that you're going to need for quite a long time. So it really comes down to watching your signs and reorganizing an addition. So if we look at number 13, we have an x to the third, an x to the fifth, and an x. We need to put it in descending powers of x. So the biggest first, the biggest power on x first. So we're looking at exponents here. So that 7x to the fifth is positive, so we'll put 7x to the fifth. X to the third is positive, so plus x to the third. And 2x is also positive, so we'll add 2x. These problems are pretty easy. Let's do one more together, and then I'll give you 2 on your own. So I've got a x to the first, an x to the second, an x to the third, and a constant. So x to the third is the largest term, or rather the largest exponent, minus 6x squared plus 1x minus 1. So it's just reorganizing the problem. Try these last 2 on your own. Here's an opportunity to check your work. And then we segue into doing leading coefficients. The best part is that this is really easy to do. The biggest piece is that when a polynomial is written, so the exponents of a variable decrease from left to right. Remember, that's descending powers of x. Exponents of a variable decrease from left to right. The coefficient of the first term is called the leading coefficient. It's as visual as you think it is. So in number 13, the leading coefficient is 7. In number 14, the leading coefficient is 4. In number 15, the leading coefficient is what? Yep. Leading coefficient is 1. And how about in number 16? The leading coefficient is 6. All right, let me flip my page over and get organized, and I'll be back to work on the back.